For this example of double angle formulas, they're asking us to use the following information, this information that's given here, and they're asking us to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. Now, they are saying and giving us that the cosine of theta is 5 over 13, and I want to explain something very quickly here before we start tackling this problem. Cosine of theta is 5 over 13. Be careful because some students might think, well, if the cosine of theta is 5 over 13, then the cosine of 2 theta should be double what the value for cosine theta is, 2 times that. And this is wrong. This is incorrect. Why is this incorrect? This 2 here is taking the value of the original angle and it's making it double. Therefore, this angle is changing its position. So let me give you an example. Let's say theta is pi halves. Let's say we're talking about this angle theta. Theta is pi halves. So let's say I want to look for the cosine of pi halves. How much is that? The cosine of pi halves is 0. Okay? Now let's look at 2 times theta. 2 times theta would be 2 times pi halves. And that would give you 2 pi over 2, which is equal to pi. So now when I look for the cosine of 2 times theta, which is the cosine of pi, how much is the cosine at pi? The cosine at pi is equal to -1. Because these are the coordinates, right, when we have our unit circle. So that equals -1. So this is important. Notice that the cosine of theta, which is pi halves, while the cosine of 2 theta is -1. You don't get the same answer. That's why you can't assume that the double angle will be just the double amount of what is given. So be careful with that. What this 2 refers to is 2 times the angle, which what it does literally, it takes your original angle and it's asking you about a different angle, not the original one. It's asking you about the double of the original angle, which will give you a different value for cosine, okay? Okay, so now let's try to answer this question. Okay, in this question, it tells us to use this information. Cosine of theta is 5 over 13 to find these double angles. And it's telling us that the angle is between 3 pi halves and 2 pi. So that places us where? That places us in the 4th quadrant between 3 pi halves and 2 pi. I have drawn my triangle, reference triangle in quadrant 4 with my reference angle theta. And this information provided, remember that cosine of theta, 5 over 13, they're just telling me how much the adjacent side measures and how much the hypotenuse measures. So I know the adjacent side to this angle measures 5 and the hypotenuse measures 13. I'm left with this side unknown, which I will need to find because if I want to find the cosine of the double angle, the sine of the double angle, I need the sine of the angle in both of them. So in order to find the sine, I need to find this side. So let's use the Pythagorean theorem. I have that c squared is a squared plus b squared. C squared is your hypotenuse, so 13 squared is 5 squared plus b squared. You get 169 is equal to 25 plus b squared. Now we isolate b by subtracting 25 from each side. And we get that b squared is equal to 144. We take the square root on both sides, and we find that b is equal to plus minus 12. Which of the two do we use, the positive 12 or the negative 12? Well, since our triangle is in the 4th quadrant, this value here is in the negative y direction, so this should be negative 12. Okay, there you have it. So now that I have all three values, one more thing I'm going to do is I'm going to find the sine of the angle, the cosine, and the tangent of the angle, because I see from my double angle formulas that I'm going to need all three trigonometric ratios. There you have your three trig ratios, and now we're going to proceed to find the sine of 2 theta, the cosine of 2 theta, and tangent of 2 theta. Okay, so let's go ahead with sine of 2 theta. Sine of 2 theta, according to the formula, it says that it's 2 times the sine of theta, cosine of theta. So here's what you do. That will equal to the sine of theta, negative 12 over 13, and the cosine of theta, 5 over 13. You multiply numerators times numerators. 2 times negative 12 times 5, that's negative 120. And 13 times 13 is 169. So the sine of 2 theta is this much, and that's your answer. Okay? Let's do cosine of theta, cosine of 2 theta. For the cosine of 2 theta, the formula says I can use this expression or this one or this one. You can use whichever you want. I'm going to use the first one. Cosine squared of theta minus the sine squared of theta. So let's plug in the values. That means this will equal, the cosine of theta is 5 over 13. So cosine squared just means the square of this value, minus sine squared theta. Sine is negative 12 over 13 squared. Okay, so this will equal 25 over 169. When we square a fraction, we square the numerator and the denominator, minus 144, that's the square of 12, and 169, which is the square of 13. We subtract these two quantities, and we get 119 over 169 negative. That's the cosine of 2 theta. That's your final answer. For the tangent of 2 theta, our formula says that we take 2 times the tangent of theta and we divide by 1 minus the tangent squared of theta. So this will equal 2 times tangent of theta, which is negative 12 over 5, negative 12 over 5, everything over 1 minus negative 12 over 5 squared, which is the tangent squared. Okay, so this will equal 2 times this is just negative 24 over 5. And in the denominator, I'll have 1 minus, the square of 12 is 144, and the square of 5 is 25. In the denominator, I need common denominator. So the common denominator is 25. To make 1 have a common denominator of 25, I'm going to multiply the numerator and denominator by 25. And then I get this much, negative 24 over 5 divided by 25 over 25 minus 144 over 25. Now I can simplify the denominator, and that gives you negative 119 over 25. Now I have a division of two fractions, which I can rewrite as a product of the reciprocal of the denominator, which means I keep my numerator and I multiply times the reciprocal of the denominator. So that means you flip it, and this is negative. So negative times negative, I will have a final result of a positive. I can cross cancel 5 and 25 just to make my product easier, and I will get positive 120 over 119, and that's the tangent of the double angle. And there you have the answer to this question. I hope you understood. If you didn't, go back, rewatch the video. Have fun.